Section 7 Ergonomics of an Anthropometry. A ergonomic. Ergo mean ergos, work, and nomos, law. Ergo. The definition of ergonomics according to Woodside and Kukurek, 1997, is an integral one between workers, jobs, tools, places, and the working environment, namely the environment whereby workers can do their jobs safely and comfortably. Ergo according to Charters, 1985, cited by Sanders said ergonomics is a systematic branch of science to harness information regarding nature, ability, limitations, and other human characteristics for designing tools, machines, jobs, work systems and the environment so that people can live and work on those systems are productive, effective, safe, and secure. Fun. According to Sanders and M.C. Cormack, 1987, defines ergonomics, human factors, with the three elevation approach, i.e. one focus. Ergonomic is the interaction of humans with products, equipment, facilities, procedures, and work as well as shelter. In drafting with products, equipment, facilities, procedures, and the environment, the problems of capability, limitations and human needs are a major consideration. Two objectives. The ergonomic primary. There are two. A. Enhance effectiveness and efficiency in working, here's including how use of convenient tools, rigging errors, and increasing productivity. B. It is developing safety, reducing fatigue and stress, enjoyable use, improving job satisfaction and improving quality of life. 3. Approach. It is the ergonomic that systematically duplicates relevant information on human capacity, limitations, characteristics, mechanisms, motivations for distributing the procedures and the environment they use. B. Comfort. Ergo. At work there is interaction between workers with machines and the environment in getting his job done. Ahmadi, 1990, stated that jobs as well as the environment are exposure on which it is a burden to workers. Any burden will give rise to tension, stresses, and strains, so giving rise to backlash for workers a taste convenient or uncomfortable. Ergo. Exposure, A. Physical, temperature, pressure, sound, lighting, radiation, vibration. B. Chemistry, dust, steam, solution. C. Psychosocial, employment relationships, management systems. D. Ergonomic, the design of tools, layout, working methods, Trenannings, 1990. Ergo. Comfy. It can mean fresh, healthy, and bodies feeling good, the great Camus of Indonesian language. Ergo. Convenience. Measurement. It can be made from feeling uncomfortable. Summa Moore, 1992, against exposure workers receive, i.e. a discomfort complaint or a bad taste in body parts due to received exposure. Discomfort complaints can be tiredness, soreness, pain, bruising, abrasions and so on workers' body parts while working using tools. Body parts that experience the buffetiness. Body parts that had their unsupported buffet at seaport raised in dysport area. Body, B.A.D, part of the body is among other neck/thick, neck, shoulder/pundak, shoulder, elbow, arm, forearm, hand/ankle, hand/wrist, finger, fingers, upper back, low back, thigh, knee, lower leg, low leg, and leg/foot joints, onskli/foot. See Figure 7.1. Sensitive body parts experience the buffetiness. See Human and Machine Systems. Ergo. Although production technology developments are developing fast, yet human factors remain significant in determining productivity. In manufacturing industry as well as the human role service industry are still relied on as components in the production process. Winoso Gibrato, 2000. Ergo. Humans are component in the human-machine system. The two production elements interact with each other to produce output. Foundations based on input. The Manasamanine interaction process is illustrated by Sander and M.C. Cormack, 1987, in the following Figure 7.2. Humans obtain input, with a look or hear, sensing, of displays the machine, the information is processed in the brain, Then the brain decides to perform the reaction of carrying out the machine control. The control makes the machine operational. The machine is installed displays to inform that the engine is in operation. The process is completed or dead. Operating the engine will process input into output. The process it happens to the working environment. See figure 7.2. Human, Machine System, Sander and M.C. Cormack, 1987, 14, Machine-Human Relationships grouped into, one manual system. On this system input gonna be direct outputs. The hand apparatus serves to add ability or capabilities in getting the work charged on it done. Humans function as a source of power and control of operations. 2 Mechanical system, this system is often called a semi-automatic. On this system power and several other functions are replaced engines. Humans gave response through control systems to operate the machine. The machine operates with human control. 3 Automatic system, on the automatic system the engine is able to carry out all functions starting to sensors, decision-making as well as action. Humans tasked with monitoring so that the machine could work properly, include data or replace new programs when needed. See figure 7.3. Some examples of mechanical, manual control tools. D. Anthropometric sense. Ergo, in the production process there is a human interaction with the machine. The interaction will be harmonious when the machine is designed according to the characteristics of the human being using the machine, for which a designer needs information about the human body dimension. Science on human body dimension measurements called an anthropometry. Ergo, anthropometry comes from the word anthro, which means human, and metry, which means size. Definitively, an anthraxometry can be declared as a study relating to the measurement of the dimensions of the Wignoso Gebrato, 2000, human body. Hughes, 2002, defined anthropometry as a science of measuring and collecting physical characteristic data and its app for design and design system evaluation, equipment, manufacturing products, facilities, and the human environment. Factors that affect the size of the human body, Wignoso Gebrato, are 1. Age. Body size will develop along with its age increase. Ages 0 to 20 make up a growing age. 20 to 40 years are relatively fixed, and ages 40 and older tend to shrink. 2. Gender. The dimensions of the male body are generally larger than that of the female except for certain parts of the body such as the hips. 3. Tribes of nations. Each tribe of nations, although ethnic groups, will have a body characteristic that differs from one to the other. The basic principle of application of anthropometry in an ergonomic design. 1. Design for the individual and extreme, maximal and minimal. Examples: the door height uses the maximum human high size for operational styling. Planning of extreme use tools is minimal. 2. Design for the average human being. This average approach is easy and cheap, yet has enormous weaknesses as only half of the population is capable of operating. 3. Adjustable design. This design is excellent, as 95% of the population are able to operate the tool, but its weaknesses cost a great deal. Manual. 4. Design for the individual. This design was made for an individual whose data was used to design. This design is most ideal for such individuals but is uncomfortable with being used in others. Anthropometry was grouped in half. Grade 1992, Sanders and M.C. Cormack, 1987, Woodside and Kukurek 1997, Hughes 2002. 1. Static anthropometry or structural is a body size on a motionless condition, the standard position of both standing and sitting position. 2. Dynamic or functional anthropometry is a body size when performing work activity in an working environment. Based on data from anthropometry we can do the design of workstations. High example of work desk for work that needs the man wrist muscles under the belly button, work table height that needs power musculature, whereas those in need the precision of the work table is above the navel. See figure 7.4. The work desk height corresponds to the type of work, I.L.O, 2010, see figure 7.5. A reach of hands while working, I.L.O, 2010, electing and designing the ergonomic hand tools. Ergo-technological developments allow hand tools to be mass-produced to meet a moment's needs. Many hand tools are produced without consideration of human factors as users of the tool, so that after potential use gives rise to health disorders in its users. The disorder can scuff, pinch, hit, cut, dislocate as well as trauma speculative. Ergonomic tool selection is one of preventive efforts preventing the occurrence of occupational health disorders due to a less ergonomic working environment, so that in the course of the less, designing tools needs to pay attention to the ergonomic principle. Principle designing an ergonomic hand apparatus. 1. Create a lightweight, conceivable hand apparatus with one hand. Tough tools cause users of fast gear to tire. This may lower work productivity. Lightly contraption yet when carrying a device must with two hands will be troublesome when in addition to that hand use efficiency is low. 2. Create compact hand tools that are light, easy to weigh in and keep. Hand tools are often used on a variety of working positions and work sites, so the design should be compact, that is light and easy to carry. Tools should also be able to be well kept to be ageless, easy to care and easy to look for when wanting to use again. Principle designing an ergonomic hand apparatus. 3. Create the handle of the tool in diameter, length, and proper shape. The tool's handle size affects the convenience and handheld power. The diameter of the handle of the tool is 30 to 45 mm with either the rounded shape or the oval, for a 5 to 12 mm diameter precision tool. Handle's length tailored to a holding way when using, whether using two hands or one hand. The handle length is 100 to 125 mm covered, and the distance with a front of 40 to 60 mm. See Figure 7.6. Handrail stick handle size. 4. Make a comfortable handle held, not slip easily, has a limiting, has high heat and electric prisoners. Gaggers can be made from wood, plastic, or rubber. The material has a high strain coefficient so that it is not easily slip, a hot and electrical insulator good so that it can protect workers from possible accidents when the tool is exposed to heat or electrocute. The rubber is a good ingredient for handle coatings because it is elastic, that it is more convenient when grip, in addition to which the rubber also has a good strain coefficient and electrical insulator. The confine to the handles is required to protect the hands from possible slips and to inflict wounds. See Figure 7.7. Stag a knife with a caper, ILO, 1996, 5. Create tools on a natural working position, avoid any deviation as well as radial on the hands. Honor as well as radial deviation when using potential tools occurs technosynovities from median nerves, median, wound to the carpi canal. Can two models of handles to avoid thing that is a seismic form, inline, and shape of a gun. The example of the handles is bent to the position of the natural hand. See Figure 7.8. Some swishing of the bent hand apparatus handles. The sound of the handles model relates to the working position. For the vertical position of the handgun model is well used, but for the horizontal working position the handle model in line is more appropriate. See Figure 7.9. The selection of the handle model is working position, Marshall, 2003. 6. Make a discrete handle with axial cultivation. The handle blade is not as bad as it will turn motion and moment. To address the phenomenon the hand does a balance of the turn reaction so that the hand's work is heavier. See Figure 7.10. The rotary crust from the hilt is not quite as, Neuromayan 2, 1996, in fact. 7. Create a machine with a weight point as close as possible to the grip to reduce rotary motion or excessive moments on the holding hand. 8. Avoid parts of the tool that have sharp corners that can cause bare-breasted injuries. 9. Create possible tools used with either left or right hand, used by a male or female. It can be 8%-10% lefties and 50% female. 10. Avoid emphasis on sensitive networks. Some device designs when used cause emphasis to occur on pressure-sensitive areas such as nerves, blood flow, particularly ulnar and radial ALT rise. Tackling the thing, then the contact surface is expanded and moves pressure on less sensitive areas, i.e. in areas between the thumb and the index finger. See figure 7.11. Emphasis on sensitive regions, Marshall, 2003. 11. Create hand tools with manpower to operate as low as possible. Power operates low-level tools, allowing workers to work more precision, convenient, small, productive rest times. 12. Create a hand apparatus with a balancing spring balance, so workers don't always need to hold on when moving tools after using tools and tools back in their original position. The power thus brings the tools to reducible and the tools can be quickly found while using again. F. Understand the ergonomic macroeconomics. Ergo, the movement the worker does. There are times when it is precise, yet there is also unnecessary motion, pseudoloxina, CS, 1980. The crust need not be wasteful of power and energy, for that we need to lose out so as not to slow production time. Ergo, in designing tools, layout, nor working methods need economic consideration of motion. In order for tools to be created, layout nor working methods capable of pinning unnecessary movement, combined motion becomes more effective and simplifies activities so that energy needs are minimal. The economic principle of motion from Mondale, 1994, 1. Elimination of activities. A. Elimination of all activities/inclined activities or movements is unnecessary. B. Elimination of irregular conditions in each activity, by putting facilities and materials on fixed premises. C. Elimination of the use of the surveillance on static activities. D. Elimination of time is empty or waiting. 2. Combination of motion or work activity. A. Replace short, sever gestures, changing course into a continental shelf, not breaking broken. B. Combine some capable movement with work equipment design. C. Distribute activities by making work balance of both hands. 3. Simplification of activities. A. Implement each work/activity with the principle of energy requirements that are used minimally. B. Reduce work objects, equipment, materials, activities by putting down unremarked places. C. Put work facilities on a normal range of hands. D. Adjust the components according to the dimensions of the human body. The economic principle of motion is connected to the human body and its movement, pseudoloxina, CS 1980, between others. 1. Both hands had better start and exaggerate the movement at the same time. 2. Both hands were otherwise unmasked at the same time. 3. Hand gestures will be easier when one against the other is symmetrical and opposite. 4. Hand gestures and bodies are best saved. 5. It's best that workers can tap into the momentum to help with his job. 6. A broken loose and direction altering crust will slow motion. 7. Jobs are best designed as young as it gets easier. 8. It's best the work beat to follow a natural beat for its workers. 9. Try little possible eye movement.